Hello and welcome to helpyourmath.com. In this video, we're going to find the zeros of a quadratic function and evaluate that quadratic function at a specific value. So here we're given function notation. This is g of x. G of x is just another way, this is the function notation way of saying y equals. This is not multiplication. G is the name of the function. X is that independent variable that's defining the function. Okay, we want to find the x and y intercepts, and then we want to evaluate g of -5. When we find this y-intercept, we do want to keep in mind that g of x is the same thing as y. So we keep that in mind as we go forward. To find the x-intercept, that means that we will say g of x is equal to 0, because to find an x-intercept, remember what that means? That means we're plugging in 0 for y. Well, in this case, y is g of x, so we would say g of x equals 0. And then we would have 0 equals x squared minus 6x plus 8. This is a quadratic. We might want to see if it's factorable, especially because if it is, we can use the shortcut and save ourselves a lot of time. Or if you love the quadratic formula, please use the quadratic formula. I'm going to factor though. So here I see we're looking for a target product of +8 and a target sum of -6. And when we come up with that winning combination, we just get to plug it right into the binomials. Two things that multiply to 8 would be -4 and -2, and that's what we want to use. So this is going to factor into x minus 4 times x minus 2. Now we set each factor equal to 0. So we would say, well, x minus 4 equals 0 is one intercept, in which case x equals 4. And then we do the same thing with this factor. X minus 2 equals 0, so x equals 2. If you watched my previous video or one of my previous videos on finding intercepts, you know that when I write them, I like to write out the point so I don't confuse myself. So the point, if we have an x-intercept of 4, is 4, 0. If we have an x-intercept of 2, that would be 2, 0, because we plugged in 0 for the g of x or for y. To find the y-intercept, what we do is we evaluate the function at 0, right? Because finding the y-intercept, so I'm going to say this equals finding the y-intercept, where we would plug in 0 for x. This is another way of saying, let's plug in 0 for x. So now we're going to work through this one. This one should be a little bit shorter because we don't have to do any inverse operations or any factoring. We have 0 squared, which is 0. We have 6 times 0, which is 0. And then we have plus 8, which is, well, plus 8. So we figure out that the y-intercept, when x is 0, is 8. And the way we write that, we put 0 first, and then 8. Lastly, it wants us to evaluate for g of -5. This means we're going to go into that function g, and anywhere we see an x, we're replacing it with -5. So g of -5. I do want to put this in parentheses because if you are using a calculator, you want to make sure you put it in parentheses so that it squares the entire value and not just the 5. -6 times -5 plus 8. And then we get -5 squared is +25. Negative times negative is positive, and 6 times 5 is 30. And then plus 8, everything's positive here. We get 55 plus 8 is 63. So when I plugged in -5, my output is 63. G of -5 equals 63. This has been an example of function notation, finding the intercepts of a quadratic function and evaluating at a specific point. Thank you for stopping by.